Hubble's law, expansion observations confirm that distant galaxies are moving away from us faster than closer ones. Redshift: when astronomers examine the light from distant galaxies, they observe that its wavelength has been stretched toward the red end of the spectrum. Distance speed correlation: Hubble found that the farther away a galaxy is, the faster it appears to be receding. This relationship suggests that space itself is expanding uniformly in all directions. Implication: if you rewind this expansion, all matter and energy in the universe must have originated from a single, extremely dense point. 2. Cosmic microwave background, CMB, radiation. Discovered accidentally in 1964 by Arno Penzias and Robert Wilson, the CMB is considered the clinching evidence for the Big Bang. Cosmic microwave background, CMB. The afterglow of the early, hot universe predicted by the Big Bang model was detected in 1964. The afterglow, theoretical models predicted that the early, hot universe would leave behind a faint glow of radiation. As the universe expanded, this radiation would cool and stretch into the microwave part of the spectrum. Uniformity: the CMB is detected coming from every direction in the sky with remarkable uniformity, corresponding to a temperature of approximately 2.7 Kelvin, minus 270 degrees Celsius. Snapshots of the past, high-precision maps from satellites like COBE, WMAP, and Planck show tiny temperature fluctuations that represent the seeds of the galaxies and large-scale structures we see today. 3. Abundance of light elements, nucleosynthesis. The Big Bang theory accurately predicts the relative amounts of light chemical elements created in the first few minutes of the universe. Abundance of light elements: the calculated ratios of hydrogen and helium in the universe perfectly match predictions of what would be formed in the first few minutes. The 3-to-1 ratio, calculations based on the theory predict that the early universe should consist of roughly 75% hydrogen and 25% helium, with trace amounts of lithium and deuterium. Observational match: when astronomers look at the oldest stars and distant gas clouds, which haven't been polluted by later stellar fusion, the measured abundances match these predictions almost perfectly. 4. Large-scale structure and evolution. The way galaxies and clusters of galaxies are distributed through space reflects the predicted growth of the universe. Galaxy evolution: observations from deep space telescopes like the Hubble Space Telescope show that galaxies billions of light-years away, seen as they were in the distant past, look different and more primitive than galaxies nearby, supporting the idea that the universe has evolved over time. Dark matter and energy: the current Lambda-CDM model incorporates the Big Bang framework to explain how dark matter helped pull early gas together into the cosmic web of structures we see today. Rebuttal/counterarguments to the Big Bang theory? 1. The expansion of the universe, Hubble-Lemaitre law. Tired light hypothesis: this historical alternative suggests that light loses energy, redshifts, simply by traveling through long distances of space, perhaps by interacting with dust or vacuum particles. If true, redshift would be a measure of distance, not expansion. Static universe models: some researchers argue that redshift might be caused by factors other than recession, such as redshift quantization, the idea that redshifts only occur in specific steps, which would contradict the smooth, uniform expansion predicted by Hubble's law. Expansion boundaries: critics sometimes argue that if we cannot observe the physical boundaries of the universe, we cannot definitively prove it is expanding rather than galaxies simply moving through pre-existing space. 2. Cosmic microwave background, CMB, radiation. Thermalized starlight: early dissenters, including proponents of the steady-state theory, argued that the CMB isn't a relic of a beginning, but rather ordinary starlight from distant galaxies that has been scattered and smoothed out by cosmic dust until it reached its current uniform temperature. Assumption of origin: rebuttals often point out that the CMB only proves the universe was once hot and dense, not necessarily that it started from a single point or singularity. 3. Abundance of light elements, nucleosynthesis. The lithium problem: standard Big Bang models predict a certain amount of lithium-7, but observations of old stars consistently show significantly less lithium than predicted. This discrepancy is a major point of contention for critics. Alternative production: critics suggest that elements like helium and lithium could have been produced in other ways, such as by generations of early, massive stars or through plasma processes, rather than in a single initial event. 4. Large-scale structure and evolution. Structures too large: some observed cosmic structures, like massive walls of